Markus Metz and Markus Neteler from Mundialis can't be here, but I am presenting. My name is Václav Petráš, and we will be talking about optimizing urban infrastructure, and specifically, they developed a system for automated trench planning for placement of optical fiber cables. The company name is Mundialis. They are a German company, and their expertise is in open data, open source, geospatial analysis, and remote sensing. And one of the products, one of their major products is an open source REST API processing tool called Actinia, which is focused on scalability, distributed processing, and interfacing with GRAS tools in the cloud. And they are using this in the project I am presenting to you today. So the goal is to place fiber optic cables across Germany, and they are using GRAS for this, and they developed this cloud-based automated workflow. The inputs for this workflow are there is many, including streets, buildings, some special things like graveyards where you wouldn't dig, and of course other things like public and private ownership. And all of these things are prepared and automatically pulled into the processing, and then the user of the application, they just provide the input area, and everything else is automatically processed for them. One critical step in the analysis is computing the cost of digging the trench. So all of that is done through the remote sensing data and sort of in the raster world, and done in GRAS. And then the outputs are the potential trenches where the optical cables can be placed. And that includes trenches along the roads, in the road center lines, and also across the roads where they need to connect to opposite sides, and dealing with crossroads and other things. From the remote sensing, they include the cost of that for the digging. And the result is a network of possible trench placements, which then is delivered to the planners, who then decide based on other properties like the potential customers where they actually will place the optical cables. But they have this optimized cost-informed network. And they are using it now for years in production in Germany to place the optical cables. As far as how GRAS is involved, besides the pre-processing, the whole procedure includes hundreds of calls to different GRAS modules. So it's heavily relying on what GRAS can do. They are using some basic tools like raster algebra, but also some more advanced tools. And the whole process is wrapped as an Actinia process. So that's the REST API. So that's how they are delivering it online through cloud. And there were some impacts to the GRAS project as well from this. As they were developing it, they were making improvements and fixes to GRAS itself. And one of the biggest one is that the vector data can now be indexed to be bigger indexes than 2 gigabytes. And the most important tools they used, some of them are very standard, like buffer and overlay. But then they also work with the network analysis to actually create that optimized network. And they were using a lot of vector topology and vector processing in their workflow, which we will hear more about later. And then what they really benefit from is that they can combine GRAS with their workflows in Shell, Python, and also C. So they included all these three languages. Everything is mixed, just what is most appropriate for the specific task. And that includes modifications of existing tools if they need to improve something in Grass or really heavily modify just for the use case, because Grass is open source.